the second video of matrix. In today's video, we will learn all about the operations which can be done on the matrices. Let's talk about the first operation which can be done, the addition of two matrices. First and foremost rule you should know that matrices of same order can be added. That is the first rule. Okay, so if you want to find a plus b, first thing is the order has to be same of a and b matrix, and then how will you do the addition? The corresponding elements will get added to the corresponding element. That means the order of a plus b, the resultant which will come, that is, suppose I call it c, the order of c will be 2 by 3, the same as a and b, and the corresponding element will get added. Yani ki a11 with b11, a12 with b12, a13 with b13, and so on. So in general, I can say Cij will be equal to Aij plus Bij for all the possible values of I and j. The second thing, multiplication of a matrix by a scalar. What is a scalar which you should understand? Scalar is anything which is a non-zero entity. Something which is not equal to 0 is a scalar quantity. So if you have a matrix A, suppose a general matrix A which is A11, A12, A21 and A22, and I want you to find K times A. So it will be, you will multiply the scalar with all the elements. That is how you will find the value of K into A, right? Any scalar into the matrix. So that is, so any, suppose I want you to find K into A, so it will be K into Aij, where Aij, you know, represents the elements, right? Alright, let's talk about the difference of the two matrices. Now, difference of the two matrices also uses the concept of multiplication by a scalar. How? We already know the concept of addition, children. So, if I multiply the second matrix by -1 scalar and then I add, don't you think I will get A minus B? So, can I say A minus B will also be only done when two matrices are of same order, and कैसे result क्या आएगा? Only the plus sign will change to minus. That means Cij will be Aij minus Bij. Okay, that is how, and that is how did we reach difference of matrices? We just multiply the second matrix by a scalar which is -1, right, children? So that is difference of matrices. Let's talk about the fourth operation, multiplication of matrices. This is a very important concept which I want you to understand. First, multiplication of A and B is not always defined. There's a rule of multiplication, and what is that rule? Let me show you. The number of columns of A should be equal to the number of rows of B. That means अगर मुझे A इंटू बी फाइंड करना है, मल्टीप्लाई करना है, तो A का जो कॉलम नंबर है, सपोज द ऑर्डर इज m by n, the order of B has to be n by something can be taken as P. So these two has to be equal. If these two are equal, then only I can say that AB exists. And the order of AB आप कैसे फाइंड करोगे? Whatever is left. तो पहले वाले का रो रह गया और दूसरे वाले का कॉलम रह गया. That is how you will find the product of two matrices. Now from here we will obtain a very important result, children. If this is the order of A and B, can I find BA? Check. Order of B is n by P and order of A is m by n. So as per multiplication is possible only if column number of the first matrix is equal to row of the second matrix. तो यहाँ पे तो P is not equal to M है, so that means BA is not possible. So we attain a very important result that AB is not equal to BA, or we can say AB and BA are not always defined. So that, and I can also say that multiplication of the matrix is a non-commutative entity. It is a non-commutative property that AB की value BA के equal नहीं आएगी. Now, if you can find AB, मतलब अगर AB exist करता है, how will you find AB? Suppose AB is any matrix C. So then the elements of CIK, that means the element of CIK, where what is, let me explain, the elements of A is represented by AIJ and element of B is represented by BJK. ऑब्वियसली ये और ये इक्वल होने ही चाहिए, तभी आप मल्टीप्लिकेशन कर सकते हो, राइट. सो जो मल्टीप्लिकेशन करके आएगा, दैट इज जो सी आई के आएगा, उसके जो एलिमेंट्स आएंगे वो क्या आएंगे, वो आएंगे समेशन ऑफ ए आई जे इंटू बी जे के. लेट मी एक्सप्लेन यू दिस बेटर यूजिंग एन एग्जाम्पल, बिकॉज इससे बहुत ज़्यादा क्लैरिटी नहीं आती है. लेट मी एक्सप्लेन यू. Okay, suppose I take an element and a matrix A 1 2 minus 1 0. I've taken a small matrix 2 by 2 order. Okay, let me take another matrix B. Multiplication तभी होगी जब पहले वाला 2 होगा और अगला वाला 3 ले लेते हैं, तो 2 rows और 3 columns. So this is minus 1, let me not minus 1 4. Okay, this is minus 2 3 and this is 0 and 1. Suppose this is my 2 by 3. 2 by 3 means 2 rows and 3 columns. So you can see that. Now let's check A into B. पहले सबसे पहले चेक करना है कि A into B पॉसिबल है या नहीं. तो पहले चेक करो, इसका जो कॉलम नंबर है वो इसके रो से मैच करना चाहिए, तो वो तो कर रहा है. और ए बी का जो आंसर आएगा C, सपोज उसका ऑर्डर क्या आएगा, जो लेफ्ट है, जो बच गया है. तो क्या क्या बचा है, पहले वाले का रो और दूसरे वाले का कॉलम. सो हमें पता चल गया सी जो आएगा मैट्रिक्स, जो आंसर आएगा उसका ऑर्डर 2 by 3 आएगा. अब एक स्केलेटन मैट्रिक्स फॉर्म करते हैं सी. 2 by 3 मीन्स 2 रोज, ए सी लिख लेते हैं, C11 C12 C13, 2 rows and 3 columns. So C21 C22 and C23. So this is 2 rows and 3 columns, children. अब इसे find कैसे करना है, how will you find C11? Now let me explain you. C11 का मतलब है first row into first column. So let me show you by sign. First row will get multiplied by the first column. So that means 1 into minus 1 समेशन, क्योंकि सम था यहाँ पे, समेशन यानी कि प्लस -1 into 4, मतलब करस्पॉन्डिंग एलिमेंट्स को मल्टीप्लाई करना है. 1 -1 के साथ मल्टीप्लाई, फिर बीच में प्लस का साइन, फिर जो सेकेंड एलिमेंट है वो इस पोजीशन से मल्टीप्लाई, मतलब 1 A I, right? AIJ gets multiplied by BJK. So this into this plus this into this. Okay. First row, first column. Now, how will you find C12? इसे read करो. First row into second column. So first row into second column. That is 1 into -2 plus 2 into 3. Now C13 again read करो, first row into third column. So first row into third column. So 1 into 0 plus 2 into 1. Right, children? Then C21, read again. Second row, first column. Second row, first column. So -1 into -1 plus 0 into 4. Then C22, second row, second column. Second row, second column. So -1 into -2 plus 0 into 3. Then C23, that is again 2 3 को again read करिए, second row, third column. Second row, third column. So -1 into 0 plus 0 into 1. And you know how to evaluate. Mathematics वो तो evaluation करना तो आता ही है. This is -1 -4, that is -5. Similarly, this is -2 plus 3 2s are 6. और 6 में से 2 गया 4, this is 0 plus 2, that is 2, this is minus 1 plus 0, that is minus 1, this is plus 2 plus 0, that is 2, this is 0, this is 0, so answer is 0. So that means we will get C, where this is minus 5, this is 4, this is 2, this is minus 1, this is 2, this is 0. So this is how multiplication becomes possible, and this is what is meant by summation, because this formula is not very clearly explained in NCERT. So that is why I have explained you this formula with the help of an example. Now from this, and obviously if you want to find B into A children, so let's check कि क्या हम B into A find कर सकते हैं. B का ऑर्डर क्या है 2/3 and A का ऑर्डर क्या है 2/2. तो चेक करिए, this 3, the column number of the first should be equal to the row number of the second. So 2 and 3 क्या आपस में equal है? No, they are not equal. So that means BA is not possible. Okay, so, and the last thing which I want you to tell, a thing which most of you skip while reading NCERT, A into B and B into A for two matrices AB will only be possible if both are square matrices of same order. How? Check करो, अगर ये मैं m by m लूँगी और ये भी मैं m by m लूँगी, तभी तो ये दोनों इक्वल होके आंसर कुछ C आएगा एंड उसका ऑर्डर जो बचा हुआ है दैट इज m by m आएगा. अगर मैं B into A करूँगी तो इसका ऑर्डर भी m by m होना चाहिए और A का ऑर्डर भी m by m होना चाहिए. अगेन ये और ये इक्वल है तो आंसर कुछ और आएगा D, but the order will be same, right? So obviously you should know that AB will not be equal to BA at all, right? This can only be equal, I'll tell you in a special case, okay, where we will talk about that in another video, okay? Otherwise, for general matrices A and B, AB is not equal to BA. That means it is not commutative in nature for any two general matrices. Let's go ahead. Let's talk about properties of matrix addition. So commutative law, addition. We are talking about addition here. So addition में A plus B matrix क्या आपको B plus A देगा? Obviously देगा, because the order of addition will not matter. Aij plus Bij or Bij plus Aij will give you the same answer. Let's talk about associative law. Again, we are talking about addition. So A plus B plus C. So this will be Aij plus Bij. पहले ऐड करो, ब्रैकेट आपको पता ही है, पहले A plus B को ऐड करो और फिर जो आंसर आ रहा है उसको C को ऐड करो. So again the order is not going to matter because addition is associative in nature. So similarly, associative law भी true hold करता है in case of addition and commutative भी. Let's talk about the third law, existence of additive identity. What do you mean by additive identity? मैं एक मैट्रिक्स में क्या ऐड करूं कि मेरा आंसर सेम मैट्रिक्स रहे? तो आपको पता होना चाहिए नल मैट्रिक्स या जीरो मैट्रिक्स. सो अगर मैं एक मैट्रिक्स में नल मैट्रिक्स ऐड कर दूंगी तो मेरा आंसर सेम मैट्रिक्स ही रहेगा. सो नल मैट्रिक्स इज सेड टू बी द एडिटिव आइडेंटिटी फॉर addition, for matrix addition. Okay, so this is just a one marker question which you should always remember. Let's talk about the fourth one, the existence of additive inverse. मैं A में क्या ऐड करूं कि मेरा आंसर नल मैट्रिक्स आए? तो ऑब्वियसली क्लियर हो जाना चाहिए, A में आप -A करोगे तो ही आपका आंसर नल आएगा, या -A में आप A ऐड करोगे तो भी आपका आंसर नल आएगा. सो दैट मीन्स आई कैन से दैट -A is the additive inverse of A, या negative of A, right? So that is all four properties of matrix addition. Let's move ahead. Properties of a scalar multiplication. ये भी बहुत सिंपल है. आप K को अलग अलग मल्टीप्लाई करो दो मैट्रिक्स से और फिर ऐड करो, या आप पहले दोनों मैट्रिक्स को ऐड करके फिर K से मल्टीप्लाई करो, द आंसर विल बी सेम. Similarly, the second case is also same, कि अगर आप K k प्लस l इंटू ए करोगे या k k इंटू ए प्लस एल इंटू ए करोगे, मतलब दो दो स्केलर का एडिशन मल्टीप्लाई करोगे एक मैट्रिक्स के साथ, या दोनों को अलग अलग स्केलर, दोनों अलग अलग स्केलर को ए से मल्टीप्लाई करके फिर ऐड करोगे, द आंसर विल अगेन बी सेम, right? So this is how it is explained, right children? Let's move ahead. Properties of multiplication of matrices. आपने ये तो सीख ही लिया था कि कम्यूटेटिव लॉ तो होल्ड नहीं करता, ए डॉट बी इज नॉट इक्वल टू बी डॉट ए, बट एसोसिएटिव लॉ होल्ड्स ट्रू. दैट मीन्स अगर आपके पास कोई तीन मेट्रिसेस हैं ए बी सी, तो आप पहले ए बी को मल्टीप्लाई करो और फिर उसके रिजल्ट को सी से मल्टीप्लाई करो, या पहले बी सी को मल्टीप्लाई करके फिर ए से मल्टीप्लाई करो, ए को फिर बी सी से मल्टीप्लाई करो, द आंसर विल बी सेम, द ऑर्डर विल बी, सो ए इंटू बी पहले इंटू सी या ए डॉट बी सी, so the order will not matter. Okay, that is how. But obviously if you will change the position of a b into c is equal to, if you do this, bc into a, so this will not be equal, right children? क्योंकि ये again commutative की तरह हो जाएगा, right? So you should know that the three matrices have to be in the same order. Order means A के बाद B के बाद C, okay, not the matrix order. All right, let's talk about distributive law. This is very very clear. आप एक मैट्रिक्स को सम से पहले दोनों को सम करके फिर A को मल्टीप्लाई करो, या A को पहले B से मल्टीप्लाई करो फिर A को C से मल्टीप्लाई करके फिर ऐड करो, द आंसर विल बी सेम. Similarly for this also, A plus B into C, you can just open the bracket, it will be AC plus BC. Okay. Now the third one and an important one, the existence of multiplicative identity. आप A के अंदर क्या मल्टीप्लाई करोगे कि मेरा आंसर A आएगा? तो मैट्रिक्स है बेटा, सो मैट्रिक्स में वन जो है वो आइडेंटिटी मैट्रिक्स डिनोट करता है. तो मैं A को अगर I से, I मतलब आइडेंटिटी मैट्रिक्स इन अ मैट्रिक्स acts as a one, so you should always remember that I acts as one in case of matrix. So A into I will give you A, or I into A will also give you A. So I is known as the multiplicative identity. This you should know. So multiplicative identity for a given matrix is I. That is identity matrix. Okay. Of obviously same order that of A for any square matrix. So this is all the properties of multiplication. All right, the next is the exercise that we will learn in the next video, otherwise the video is going to be very very lengthy. So stay tuned for the next video, that is the solving of exercise 3.2, applying all the operations. Thank you children.